Hey everyone. Today, this video is going to be about activity number 2. So go ahead and pull up activity number 2. So first, what we're going to do is we're going to do hopefully a little bit of the review of the material that you should have read in the textbook. And then we're going to do parts 3 and 4 of activity number 2. I would say watch the first part of this video, get some understanding about the different types of number systems if you need some clarification, then do parts 1 and 2 of the activity, and then come back to this video and we're going to work through parts 3 and 4 together and kind of talk about these number system type things. With that being said, let me share my screen here. Just a second. Okay. So here we go. Hopefully everyone can see this. Great. We have, if you were in the reading, we had lots of different types of number systems, right? The first type of numbers, or I guess that we have to talk about are, we had cardinal numbers, we had ordinal numbers, and then we had identification numbers. Identification. So I just want to make sure that we're all on the same page here. So the first type of number I have written down is a cardinal number. So a cardinal number is just counting. That's what a cardinal number is, right? So yeah, they're whole numbers, but it's like counting. So an example of a cardinal number is there are 5 apples on the tree, right? That 5, right, is how many apples there are. We counted them. So that's what it means. So let me do an example. So let's say, I'll just say there are 5 things in the set. An ordinal number is something just a little bit different. So an ordinal number is where the number has an order, right? It's almost self-explanatory from the name, an ordinal and order, but not quite. So an example of like an ordinal number would be if I have a bunch of things in a line, right? And I say the 5th person in that line is going to win a prize, right? So they're ordered, but they don't mean anything, right? So it's using a number to put things in an order or indicate an order. So I'm actually going to erase identification so I can have more room here. So an example of an ordinal number is like the 5th person in a line wins a prize. Okay. That's the difference between cardinal and ordinal. Okay. And then there's one more type, and it's the identification. So the identification is using a number as like a label to identify something. So like, for example, the number on my badge is 243, something like that, right? So look at those examples. They're all kind of different, right? Cardinal is counting them. Ordinal is just kind of putting an order on something. And then identification is just, yeah, it's a number. Like the zip code of, Pittsburgh, California is 94565, right? It's just used as identification. There's no order to it. We're not counting anything. So those are really the 3 different types of numbers, okay? So the other thing I wanted to like kind of review in a sense is these different systems that people used. Okay, so these are going to be the systems. I'll put it on the page so we have more room. So hopefully you did some reading and found out about them. So we had the Egyptians. Okay, they used something called the grouping system. Grouping system. So what is the grouping system? Well, they specifically did groupings of 10. Of 10. So if you're working through, the activity, that's the little man in the staff there, right? The um the Roman numeral system. So Roman numerals, that's a positional system. What do I mean by positional? I mean where I put two characters or two symbols next to each other, depending where I put them, what position I put them, gives me a different number. So for example, this number is not the same thing as this number. One of those is 4 and one of those is 6, right? So it depends on the position. Okay. The next one was the one that the Babylonians and Mayans use. Okay, the Babylonians and Mayans, what did they use? They used something called the place value system. Okay, place value. That number, or that, sorry, that not that number, that word should sound very familiar to you because that's actually the type of system we use. So the Hindu Arabic system is what we use. Okay, and that's a place value system. Okay, so we have different place values, which is different than positions, right? So for example, this corresponds to a 1 and this corresponds to a 5, but that number is not 15, right? So that's how positional is different than place value. Because if we saw 1, 5 in our number system, that would be 15, right? So that's kind of how they're different. Our place value system, though, is multiplicative. Why is this true? Why is it multiplicative? It's because we multiply each digit by its place value. Okay? Because let's take for example 52. Well, the 5 in 52, okay? What does this mean? This means 5 times 10, right? So the place value, remember, hopefully we remember this. We have the ones, and then the tens, and then the hundreds. I'm going to do some foreshadowing. This is 10 squared, right? And then we'll have the thousands, which is 10 cubed, and so on, right? So since I write 52 this way, that is 5 in the tens place, which means it's 5 times 10. Okay, it's also additive. Why is that? Well, that's because 52 is equal to 5 times the 10 plus 2 times the 1. Okay, so it's additive. We get to add these place values together. All right, so that's kind of the review of things that might help you do activity 1 and 2. So go ahead and pause the video now if you haven't done activity 1 and 2. And if you have done activity 1 and 2, just go ahead and keep watching. I'm going to pull up this right here. Okay, so this is the number 2 activity, right? So it says you should do parts 1 and 2. And before starting part 1, read those chapters. I kind of did a really fast review of stuff. So go ahead and answer part 1 and do part 2. Okay. But what we're going to do is we're going to do part 3 and 4 together. Okay. So let's go ahead and talk about part 3. So we're put on a world. This is what it says. And they only know 1, 2, 3, 4, and 5. So only the things you can count on your hand. Now I'm going to preface that this is going to get very weird. Okay. But that's okay. That's why we're working through it together. Okay. So they only know 1, 2, 3, 4, and 5. So if I look at that first picture, I have something that looks like this. And we'd want to say that's 6. But they don't know the number 6, right? all they know is 1, 2, 3, 4, and 5. So what we want to do is come up with a way to represent the number 6. So how are we going to do this? Well, the way we're going to do this is there's a couple different ways, and if we were in class together, we'd explore all these ways, but I'll write down some of these ways. We could represent this as 5 plus 1. That's one option to do, right? We can also represent this as 5 and 1. Either of those are perfectly acceptable, right? We're creating this system together. So as long as we're consistent, we should be okay. So let's do this one. So this would be 5 plus 2, or like 5 and 2. And this one is 5 plus 3, or 5 and 3. And this one would be 5 plus 4, or 5 and 4, right? Like we don't know we don't know the digits 6, 7, 8, 9. And then the next one we're going to look at is actually digit number 10. How are we going to do digit number 10? Might be a little weird, but we'll try to figure it out, right? So how do we count the number on both hands? Well, we could just do 5 and 5, or 5 plus 5. Those are both reasonable, right? 5 plus 5, or 5 and 5. But now we've come to a roadblock, right? Like what happens if we want to do 11? So let's try to do 11. Let's think about it real quick. What would we have to do? Well, we can't go above 5, right? 'Cause they only know digits 1 through 5. So we'd have to write this as 5 plus 5 plus 1. Right? We could also write it as 5 and 5 and 1. But a lot of times what happens is when people develop these number systems, so long ago, is they would use symbols. Okay? They would use symbols to try and essentially make their lives a little easier. So what we're going to do is we're going to do the same thing. We're going to say 5 is equal to star. It doesn't matter the symbol you use. Use circle, triangle, doesn't matter, but we'll do 5 as a star. So that means I can write the number 11 as star plus 1. Star plus 1. Okay, so using 5 as a star, let's see if we can answer these other questions here. So how would we count to a dozen? So for those of you that are unfamiliar, a dozen is 12, and a baker's dozen is 13. So I got those little cupcakes there. Okay, so let's do the dozen. So we could write this as star plus 2. And we could write this one as star plus 3. Okay, so we're still fine, right? We're still okay. But let's take a look at this next one now. These are going to start to get a little, we're going to have to be a little creative here. So let's try this next one. So what I want to do is I want to see how many people are seeing this show. So what I'm going to have to do is group these into groups of 5. So let's see. That's a group of 5. That's a group of 5. That's a group of 5. And that's a group of 5. So I have 4 groups of 5, and then 3 people left. So I could write this as star plus star plus star plus star plus 3. But now look what happens. If I go down to this deck of cards, if I start grouping them by groups of 5, I have 1 group of 5, 2 groups of 5, 3 groups of 5, 4 groups of 5, and now I have 5 groups of 5. But I've now used up all of my groups of 5. I can't have 6 groups of 5 because I don't know what that is. So what we need to do is make a new symbol to symbolize 5 groups of 5. I'll just use a smiley face. We'll say smiley face is equal to 5 groups of 5. Okay, so let's go back to highlighting these groups of 5. So I have one group of 5 highlighted in purple. Let's try another group of 5. So that's 1, 2, 3. Oh, this is going to get tricky. 4 and 5. Okay. So now I have 2 groups of 5 groups of 5. Okay. So that means I have 2 smiley faces. Okay. And then how much do I have left over? Well, I have left over 2. Okay. So this is kind of how the number systems were developed. You kind of started with, okay, I have a limited number of things. And once I go past those things, I'm going to need a symbol to represent those things. Okay. So that's kind of how it started. Now, just like we did here, we're going to move on to base systems, right? So before we only had really these grouping ones, which was similar to like the Egyptian model of numbers. But these base systems, these are really the place values, okay? These are really the place values. So you can see that this number right here, 8723, I can write that as 8 times 1,000 plus 7 times 100 plus 2 times 10 plus 3 times 1. And I went ahead and put these on this sheet for you right here. Those are the place values, right? So what we want to do is we want to say, okay, we can do this. If I give you a random number, can we write it in its expanded form? Sure. So I'll give you a number. How about 2,345? Okay. So take 30 seconds. Go ahead and pause the video if you want to. And we'll go ahead and write this out. So if I do this, what is this going to be? This is going to be 2 times, well, 1,000. Well, let's see. This is 10 to the 0. That's 10. 10 to the 1. 10. Did I do this right? Nope. I counted wrong. So that's 10. This is 10 squared. This is 10 cubed. We just keep going up by powers of 10. So if I have 2,000, this is going to be 2 times 10 to the 3 plus, well, what's my next digit? My next digit is 3 times 10 squared. My next digit is 4 times 10 to the 1 plus 5 times 1. Okay, 10 to the 0 is just 1. So we can write it this way. Now, this is the number system we use. This is base 10, right? We go up by powers of 10. But we don't always have to go up by powers of 10. In fact, a lot of people use base 2. They go up in powers of 2. So if you do computer science or something, right, they would use base 2. So let's take a look at base 5. So using the same logic that we did up above, we could do base 5. So this first number place is going to be a 1. The second one is going to be a 5. The third one is going to be 5 squared. And the fourth one is going to be 5 cubed. And we could keep going. It would be kind of nice for us, right? We'll write out what 5 squared is. That's 25. And 5 cubed is 25 times 5, which is 125. Okay, so what I want you to do is take, once again, 3-4 minutes. Go ahead and try and fill this out, the part 2 here, and see if you could even do part 3, and then come back to the video. And what we'll do is we'll try to fill it out together, and then, you can check your answer. So go ahead and pause the video right now, and then we'll come back. So pretend the pause is over. We're coming back to it, okay? So we want to write what is a dozen, or 12, in base 5. Okay, so let's see. So 12, if I was to write out the number 12, well, this is really what? It's 10 plus 2. Okay, that's what 12 is. This is really, if we're in base 10, it's 10 plus 2. So what I want to do is translate this to base 5. Okay, so 12 in base 5, well, I'm going to have a ones place and a fives place. Well, I'm going to need 2 fives to make that 10. So I'll put a 2 there. And then I'm going to need 2 ones to make the 2. So this is going to be a 2 here. So how do we write a dozen in base 5? We would write 2, 2, and then we put a little 5 at the bottom to let people know that we're in base 5. So that's how we do a dozen. Let's see if we can do a deck of cards. So a deck of cards, in case you don't know, let me erase this. A deck of cards has 52 cards. So the deck of cards equals 52. So let's see what we're going to need for this. So I'll go ahead and put a 25 here, a 5, and a 1. So for 52, we're going to need 2 25s because that's going to give me 50. So it's always nice to start kind of with that highest spot and see how many I need until I go over. So I take 125 and go, yeah, that's fine because 25 is less than 52. So I take a second 25 and I go, okay, yeah, 50 is also less than 52. But if I were to take a third 25, I'd go over. So I know I only need 2 of those 25s. And I move to the next thing. So now I'm at 50. If I add one of the 5s, well, now I'm at 55. Well, 55 is already bigger than 52. So I need 0 of those 5s. And then I need 2 of the 1s. So to write a deck of cards, or 52, in base 5, it's 202 with a little 5. What about 3 decks of cards? Can we do 3 decks of cards? Of course we can. So first of all, let's see what 3 decks of cards is. So that's 52 times 3. And if we do this, we get 156. So let's see if we can do this. So I know I'm going to have a 125, a 25, a 5, and a 1. Okay, well, let's see here. I know I need 125, and I don't need any more than that because then I'm over it. Okay? If I add 25 to 125, I'm at 150. So that's good. I'll take one of those. Okay, now I'm at 150. So if I add 5 to one of those, now I'm at 155. Well, okay, yeah. So I need one of those. And then I just need one more. So that means 3 decks of cards is written as 1111 base 5. So then you can see we can do this with basically anything, right? So let's talk about D. What are the place values? Well, we've already talked about it. They're just the powers of 5. But why do we only use the digits 1 through 4 in base 5? Notice none of our other things, right? They never went above 1 through 4. Why would that be true? So let's pretend. So I have my place values here. Here's 1, here's 5, here's 25, and here's 125. Let's pretend I had 5 5s. Well, what happens if I have 5 5s? I really have what? 25, right? If I have 5 5s, I have 25 things. So this 5 5s here, that would really just be a 0 and a 1 over on the 25 spot. Okay, so that's why we only use 1 through 4 in base 5, because as soon as we did more, then we'd have to bump up to the next place. Okay, all right. So can we use any whole number as a base? Heck yeah, we can, right? we can do base 6 if we wanted to. We could represent anything in base anything at this point. So I'm going to go ahead and leave the actual work here to you, but I'll go ahead and give some of the answers. Okay. But I want you to verify that you can do these yourself. Okay. So we already know what the digits and the place values are, right? The digits are 0 through 5 because we go one less. And then the place values are just the powers of 6 again, right? So if we want to talk about, okay, what is 3 decks of cards in base 6? Hopefully you get 4, 2, 0, right? So hopefully you get this base 6. Maybe reason to yourself what that would be, and then go ahead and try part C by yourself. Okay, and now what we want to do is we can represent numbers using objects or drawings. So for base 10, we have these little building blocks. Okay, and those are the things that if you look on the syllabus, I said you could cut out. So these concrete objects, they're super useful for children. They're not just for children. I teach a college algebra class and I use these building blocks in my college algebra class. So what we're going to do is we're going to say, okay, these building blocks, generally speaking, one little block, it's called a unit, and it's equal to 1. We have one of these, it's called a long, and it's equal to 10. And then we have a big, looks like a big block, it's called a flat, and it's equal to 100. Okay? And what we want to do is we want to write out these numbers using these building blocks. So if I take the number 123, and we're all in base 10, right? Because that's what we count in. So that's what we're going to be using for elementary school, right? Is 123, well, what is 123? That's 1 times 100 plus 2 times 10 plus 3 times 1. So what is it really? Well, 100 is a flat, so it's a big one. 2 times 10 is 2 of these longs, and then we also have a unit. Okay, so that's what 123 is, and using these building blocks is actually great. Students really do love them. Okay, so now let's try doing this in base 5. So if we're in base 5, we just need to change it, right? So this is still going to be a unit. The longs now, though, rather than being 10, are going to be 5, right? So this is just going to be 5, and one of the flats is 25. You're still just using those place values. So you can use these blocks for any base you want. So now let's write 123 with these blocks. Okay, well, 123 in base 5 is 1 times 25 plus 2 times 5 plus 3 times 1. Is that true? Right? That's what it says it is, right? So let's see if we can do it. This is a big block plus 2 smaller blocks plus 3 little blocks, right? That's exactly what this 123 in base 5 says. It says I have 1 25 block, 2 5 blocks, and 3 units, right? So the blocks help because it's the same thing almost, right? I mean, it is. It's exact. Oops, I forgot to do this. There we go. On the base 10 one, make sure you have 3 of those there. I just forgot to draw them. So look, using these blocks, right? They're just place value blocks. So 123 in base 10 means the same thing as 123 in base 5. The actual number isn't the same, right? 123 in base 10 is like 123 as we know it. And 123 in base 5 is, what's that, 38 in base 10? But that's fine, right? The blocks still provide a visual aid for students to look at and help them understand place values. Okay, that should be everything we have. You can now do the exit ticket. So I will see everyone next video.